Welcome to Direct Variation, Algebra 1, Chapter 5, Section 2. In the last video, we talked about slope. One of these does not show the formula for slope. Do you know which one? Well, we know slope is rise over run. We know this is a formula for slope, especially if we put an m equals in front. This is not. Our slope is our vertical change over our horizontal change, not the other way around. Now, if we have a horizontal line, we have a run, but no rise. So with no rise, we have 0 over whatever number this is going to be. On a vertical line, we have a rise. We have a number for the rise, but it does not run. So we have a 0 on the bottom. Anything divided by 0 is undefined. So a vertical line has an undefined slope. We do have a bit of vocabulary. We're talking about direct. Direct is an adjective. It means straightforward. In math, it's a ratio of two variables is constant, then the variables form a direct variation. And we have this formula for direct variation. It's y equals kx, where k is the constant of variation. It's the constant k. Take a moment and appropriately fill in these words, and then restart this video to check your answers. Let's see how you did. Renee gave the visitor directions to the museum. The fans went directly to their seats, and there is a direct connection between the outside temperature and the number of people at the beach. So this creates a function in the form y equals kx, where x cannot equal 0. Y equals kx represents a direct variation. The constant of variation, k, is a coefficient of x. So to determine whether an equation represents a direct variation, solve it for y. And if it comes in the form y equals kx, nothing else, don't add anything to that, k cannot equal 0, it represents a direct variation. So direct variation, the ratio of two variables is constant and can be represented in the function in the form of y equals kx. K is called the constant of variation, but it's just the slope. Graphs of direct variation must pass through the origin, which is the point 0, 0. Looking at this equation, is this a direct variation? It is, because it flows in the pattern y equals kx. In this case, our k, our constant of variation, will be 1/4. It's the number in front of the x. Another equation. Is this equation a direct variation? Does this equation fall into this format? It does not. It does not, because this plus 7. That is not in our format at all. So it is not a direct variation. We know that direct variation must be an equation that looks like y equals kx. So if we have a different type of equation, we need to rearrange it to put in that format to see if it works. So let's do that. First, to complete the steps, we write the original equation. And then we're going to subtract 4x from both sides. So I'm going to get 5y equals 0 minus 4x. Now I'm going to divide both sides by 5. And remember here, I had 5y equals negative 4x. So I'm going to have y equals negative 4/5 x. Now that is in the y equals kx format. So this is a direct variation with a k equaling negative 4/5. In a direct variation equation, we don't always need to know what the k is. We can find that out. To find that out, we do need to know what one value of y and one value of x's. We know that our function is going to be y equals kx, but we don't know what our k is, so we need to determine that. So I'm going to put my y in for my y value and my -2 in for my x value. And then I'm going to solve for this k. To do that, I'm going to divide both sides by -2. So I have -20 equals k. So now I rewrite my equation by solving -20 in for k. Then I can use what I know to determine what y is when x is -15. Now remember, my k is -20, my x is -15. If I multiply those together, I'm going to get a positive 300. So my value of y when x is -15, y equals a positive 300. K can be found using just one ordered pair. So in my first example here, I have my ordered pair 12, 24. So I have x equal to 12, y equal to 24. Use my formula, but I'm going to put 24 in for the y, 12 in for the x, divide both sides by 12, and I'll see that 2 equals k. So I can now write a new formula. Y equals kx becomes y equals 2x, because k is equal to 2. Now below that I put a second type of equation. In this one I have the point 12, 8. But it not only wants me to find the equation, but also what happens when y equals 1. Well, I'm still going to use my direct variation equation. I'm still going to put in 8 in place of y, 12 in place of x, based on this information right here. Divide both sides by 12. So I have 8 twelfths equals k, and of course, being a math student, I'm going to reduce. So I have 2/3 equals k. Now I go ahead and I put that into my equation in place of the k. The value that I know, y equals 1, put that in place of the y, and it states that I want to find x, so I'm okay with x remaining a variable. To get rid of the 2/3 in front of the x, I multiply both sides by the reciprocal. So 3/2 equals x. In this example, we are looking at the weight of a moon, which varies directly with the weight on Earth. A person weighs 100 pounds on Earth. So x, our Earth weight, is 100 pounds. And same person weighs 16.6 pounds on the moon. So what's the equation that relates the weight on Earth, x, and the weight on moon, y? What is the graph of this equation? Well, to begin with, we need to find k. We need to find our constant. So y, 16.6, equals k times x, which is 100. Divide both sides by 100. So 0.166 is our k. So to the nearest hundredth, it's 0.17. So y equals 0.17 times x. Using this equation, we can put a variety of values for x in and get a set of y's so that we can then create our graph. There are two things we know about the graph of the direct variation equation. One, the line passes through 0, 0. And second, the slope equals k. K is the slope. So looking at an equation, let's say we're looking at this equation right here, we can determine if this is a line that's a direct variation or not. We can substitute 0, 0 in, that's the point 0, 0 in, and see if it's on this line. If it's on this line, then the graph is a direct variation. So 0 in for x, 0 in for y, -2 times 0 is 0, and of course 0 plus 0 is 0. So this is not true. And because that does not pass through 0, 0, that equation, -2x plus y equals 3, does not pass through that, the equation is not direct variation. Because remember, there's two things that must happen. It must pass through 0, 0, and the slope of the line is also k, and k is the slope of the line. As you can see, we have a table. Now, this information on this table is not necessarily a direct variation. To determine if they are, we need to write each ordered pair as the ratio of the y-coordinate to the x-coordinate. So for each one, we write it as y-coordinate to x-coordinate. So we're going to put 2.25 over -3. If I divide that out, it's -0.75. And again, that's a negative sign. And this one is obviously, and again, it's -3 over 4, which of course is -0.75. Now, all three of these have the ratio, have the y over x, have the constant, -0.75. So y does vary directly with k. And this means our equation for direct variation is y equals -0.75x. Please finish up the lesson check and then gauge yourself on your math success. Bring any questions to class tomorrow.